Flip back in your notes and find this reaction. The aluminum is replacing the hydrogen, and that kicks out the hydrogen to be by itself. So this is a single replacement reaction. In this reaction, the nitrogen gas and the oxygen gas combine to form the N2O. When you have one product, that indicates that you have a synthesis reaction. In this reaction, we have phosphoric acid breaking down into water and P4O10. This is an example of a decomposition reaction. Here we have iron 3 oxide and sulfur reacting. The sulfur is going to kick out the oxygen. I drew it wrong at first. And the oxygen then is going to be by itself, and the sulfur is going to bond with the iron. So this is a single replacement reaction. This reaction is an example of a combustion reaction. The way that you can know that it is a combustion reaction is because it starts out with a hydrocarbon. In this case, the C3H8 is propane. It's made of hydrogen and carbon, so we call it a hydrocarbon, and we're reacting it with oxygen gas. The products, and this is what you need to memorize, are carbon dioxide and water. In order to finish this equation, we first have to look up each of the ions that form the reactants. We have copper plus 2. That charge comes from the Roman numeral 2. And then we look up hypochlorite on the polyatomic ion sheet, which is ClO negative. We switch the charges and we get Cu parentheses ClO parentheses 2. To that we are going to add ammonium, which is NH4 plus, phosphide, which is P negative 3. We again switch the charges, put parentheses around the ammonium, write our 3, and then put our phosphorus with a subscript of 1, which we don't write the subscript 1. Now, for the right-hand side of the equation, reminder that we put the positive with the negative and the positive first. So the copper is going to bond with the phosphorus. Copper is a plus 2, phosphorus is a minus 3, and we switch the charges, getting Cu3P2. So those two are gone. Now we have the ammonium and the hypochlorite left. We put the positive one first. So NH4 plus bonds with ClO negative. The 1 and the 1 cancel out, so we get NH4 ClO. And I shouldn't have written that negative sign there, so I'm going to cross that off. Now let's try to determine what type of reaction it is. We see that there is no water on the right-hand side as a product, and therefore that's a good indication that it is simply a double replacement reaction. The copper is replacing the ammonium and bonding with the phosphorus, and then the ammonium switches and bonds with the hypochlorite. So it's a double replacement reaction. For this reaction, we first need to look up the charges of each ion. Chromic acid has an ion, a cation of H plus because all acids have H plus. This acid has the ending of ic, so we change it to 8. We look up chromate, which is CrO4, -2, and we switch the charges and get H2CrO4. We're going to react that with calcium hydroxide. We look up the calcium and see that it has a Ca plus 2. Hydroxide is an OH minus 1. And then we switch the charges. It's really important to remember the parentheses around hydroxide. Those are easy to forget. So we get Ca parentheses OH parentheses 2. Now, what are we going to get on the other side? So we are going to put the positive with the negative and the positive first. So from the first compound, we have the H plus 1. From the second, the OH negative. The 1 and the 1 cancel out, and we get HOH, which is the same as water. We are then going to take the Ca plus 2 and the CrO4 minus 2 and make a bond with them. We put the positive one first because we always put positive with negative and positive first. The 2's cancel out, and we get CaCrO4. Now, we can try to determine what type of reaction this is as well. It does have water. It has, over on the left-hand side, an acid reacting with a base, and so this is a neutralization reaction. In our very last equation, we see hexacarbon and decahydride. Those are prefixes. So the hexa tells us there are 6 carbons bonded with 10 hydrogens, and we're reacting that with oxygen gas. And what we can see right away is that this is a hydrocarbon bonding with oxygen gas, so it is a combustion. And the products of a combustion reaction are CO2 and H2O.